Oops, let's go back one. So let's actually find some vector components using trig. A student walks 2 miles at 30 degrees west of south. Find the north, south, and east-west components of the displacement. So I'm going to sketch out my vector. It's about 2.0 miles, and it's at 30 degrees west of south, which means if we started south, we rotate our resultant to the west to get it. So this angle's 30 degrees. To figure this out, I'm going to draw a vector right triangle. The legs are my components. The resultant is my hypotenuse. So I could do a triangle down, one leg, another leg, and call this SY and SX. Forms a right triangle. Then we use trig and the Pythagorean theorem to solve for the components. Let's solve for SY first. Well, SY is adjacent. It's the leg that's adjacent to the angle. And we know the hypotenuse. So we need the trig function that's going to relate the adjacent leg and the hypotenuse. So using SOHCAHTOA, that's going to be cosine. Cos theta is adjacent over hypotenuse. So I would write that as cos of 30 degrees is equal to, the adjacent leg is just SY. The hypotenuse is 2.0 miles. So I just solve for SY by multiplying by 2 on both sides. Let's do another example. Move a little faster. Cannon is fired off a cliff at 35 degrees below the horizontal. So let's draw that. This is the horizontal. 35 degrees below means it's below 35 degrees. And, whoops, it doesn't give us an initial speed. Let's say initial speed is 22 meters per second. So that's 22 meters per second. We want to solve for Vx and Vy. Vx is adjacent to the angle 35 degrees. So we'll use cosine. Cos of theta, cos of 35 degrees, is adjacent, Vx, over hypotenuse, 22 meters per second. Solve it. We get Vx equals 22 meters per second, cos of 35 degrees. Plug it into a calculator. 22 cos 35. 18.0 meters per second. That's equal to Vx. To find Vy, well, Vy is the opposite leg. So we got it, and we know the hypotenuse. So opposite and hypotenuse is related by sine. Sine of theta, 35 degrees, is equal to opposite, Vy, over hypotenuse, 22 meters per second. We solve it, multiply both sides by 22. Vy equals 22 meters per second times sine of 35 degrees. Plug it into a calculator. 22 sine of 35 equals 12.6 meters per second. Once you get the hang of it, it gets really, really easy. Let's do a couple more. The car experiences a leftward acceleration of 12 meters per second and a forward acceleration of 5.5 meters per second. Find the components of the acceleration. So the leftward acceleration is about 12 meters per second squared. And the forward acceleration is 5.5, so that's going to be smaller. 5.5 meters per second squared. Our resultance connects here and here. So we call that A. This is a little bit of a trick question because we're already given the components. 12 meters per second squared would be the x component. Maybe negative 12, if we say right is positive. 12 meters per second squared. And the y component is just 5.5 meters per second squared. To find the resultant, we would just need to use the Pythagorean theorem. One more example. A baseball is hit at 33 meters per second at 18 degrees from straight up. Find the components of its initial velocity. Now there's no coordinate plane given here, but let's just draw it anyway. It's fired at 18 degrees from straight up. So if we start straight up, this is straight up. It's 18 degrees from that, so I will rotate 18 degrees out from straight up. It's going to be something like this. 18 degrees. 18. No, I'm going to just make that triangle a little bigger, exaggerate it quite a bit. 18 degrees. And it's 33 meters per second. That's our velocity. So now we need to draw our vector right triangle. One component of the vector starts at the tail and it's going to point up. The other component points horizontally. So we get a right triangle that looks like that. Notice that our resultant is always the hypotenuse. I want to find Vx, Vy. To find Vx, well, Vx is opposite our angle and we know the hypotenuse. Opposite and hypotenuse, that's sine. Sine of theta is equal to opposite over hypotenuse. We solve it, we get Vx equals 33 meters per second times sine of 18 degrees. Plug it into a calculator. 33 sine of 18. 10.2 meters per second. Our y component, well, that's adjacent to our angle. That's the adjacent leg. And 33 is the hypotenuse. So let's cosine. Cosine of 18 degrees is equal to adjacent over hypotenuse. 33 meters per second. Solve it for Vy. Vy equals 33 meters per second times cos of 18 degrees. 33 cos of 18. We get 31.4 meters per second. So that tells us that the ball is initially moving up at 31.4 meters per second and to the right at 10.2 meters per second. And it's going to be really important to break vectors into components in a lot of situations, because it can turn a hard two-dimensional problem into two easy one-dimensional problems. If we know how fast the ball is moving up, we know it's accelerating straight down, we can just analyze its vertical motion independently of its horizontal motion. I hope that was helpful. Bye.